Welcome to Chip Logic Studio, and in this video we will discuss about packed versus unpacked array in SystemVerilog. This is concept of Verilog as well as of SystemVerilog. Other arrays like associative array, dynamic array, I will make this video after this video, so subscribe my channel. So let's move forward to our current topic. And as all of you know, in different languages there are arrays, and all the arrays have same job, is to store collection of data elements. Elements means either it will be integer, bit, or any other data type. Arrays can be packed and unpacked. This is happening only in hardware language, and understanding the difference between them is crucial for writing efficient and correct HDL code, especially for synthesis and simulation. So this part you will know this completion of this video, so watch this full video. First is our packed array. Packed array are arrays where all the elements are stored continuously in memory. So continuously in memory means this location of this memory is continuous. I will tell you with the example here written. Logic 7:0 means 8-bit byte data, 8-bit packed vector of logic type. So let's have this in another page. So here this memory will have 8 locations. So we'll divide it into half, then this half, then this half, then half. Now another thing is it is big endian format, means 7:0. So our memory location will be 7, 6, 5, 4, 3, 2, 1, 0. And the first location will store this data from 0 to 7. So what is happening here? This is continuous memory from 0, 1, 2, 3, 4, 5, 6. All the data which will be stored, like let's say X, will be here in this memory. And if you store only 3 bit of data, then other memory location will be X. Or there are other methods you can understand this concept, or I will make another video for that, how it is optimized after writing this thing. So I will make another video for that, but for now you can say this, that this memory is continuous. We will focus only on packed and unpacked array, and we will take this example also, memory. So now because this is continuous memory, we will have continuous locations. What is that location? Is 4:7:0 memory, means we are having 4 arrays of 8-bit. For example, this array, let's say this array is array 1. Okay, so this array 1, array 0, array 1, array 2, and array 3, and this will be one array. It is for visualization. In reality it will be like this will be one array, 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 and with the continuous memory locations. Continuous memory locations means this will be 0, 1, 2, and 3, and in that also there will be 0, 1, 2 up till 7, up till 0 to 7, up till 0 to 7, up till 0 to 7. So you can see, for example, if your memory location is 7, then this might be 8, then 8 to next 15, then here 16, something like this. Means memory location will continuous in 2D packed array also. This is example of our 1D packed array, and this is example of our 2D packed array. So what is written here? 8-bit packed vector, 4 elements, means 4 arrays, each of 8-bit wide packed array. Okay, now declare inside the square brackets of data type that you have seen in the example, useful for representing data and at the bit level like buses. For example, in APB protocol, if the data is there, you will say make a packed array in your P data or PR data, because it is a bus. You need continuous memory. synthesizable and manageable as a single unit. So this type of array is synthesizable. Unpacked array is also synthesizable if it is a fixed sized. can be indexed as a whole. For example, memory 1 3 access bit 3 of byte. Okay, one more thing. If you are making an array like array 7:0 and you are just making concatenation and storing this data, it is also possible. You can also ask a of 1 and you can store data like 3 here. This is also possible. You can also store like 1-8 8-b 1 2 3 4 5 6 7 8. This is also possible. But this method, last method, like you are directly storing the 8-bit data inside the array, it is only possible in packed array. Otherwise, unpacked array you can only store like either in concatenation. This is only our representation, but inside we will only like this a of 1 or 3. This is not possible in our unpacked array. Okay. Unpacked array are arrays where each element stored separately, which we will see with the help of example, and they represent a collection of variables, not bits. Means it is not continuous. We will store the element differently. Means what? In representation, it will help you in our next topic. I will just store it like this. For example, this is one array, this is one array, this is one array, this is one storage location, you can also say. So like this, there will be from 0 to 7th location, and every element will be storing in one space irrespective of their position. And this total full array we will call it 7:1. This is unpacked array. But means what is happening here, you can also say like this 0 to 7. Okay, so this is our first example 1D of unpacked array, which is written at the right hand side of the data type, and in here you can see it is in packed array. We have written this at the left hand side of our variable in our logic data type. So this thing is there. And okay, now 2D unpacked array. So okay, it is like this. So I will rub it first. It is only for representation. So as it is stored in different locations, so we cannot guess where it is stored, but for now, for representation purpose, we will say that this is our first array. What is the array num? Okay, it is 7:0 and 3, means 4 elements here also with 8-bit array. So here will be 4 elements of array like this, different locations. In packed array it was same location. Here 0 to 7. This is format for little Indian, but we are using our big Indian format, so we will be from 7 to 0. So don't get confused in this format. 7 to 0, and here it will be 4 to 0 like this. So this format will be there for our 2D of unpacked array, which will be having 4 arrays in different location, and in that also the location of the elements may be different. So what are the methods you can store this array? You can say array of, let's say it is okay, you can store full array if you want, but we will first start our basic method. You can store like at 0th location you are storing 1 like this. Second method is our advanced method used in SV. Okay, there is not a bracket. Okay. No, it is like no. So there is like a equal to, you can store directly 8 locations here. You can say 8 location. Okay, so what is happening here? It's a of 0, a of 2, a of 3 like this. So means this is following this format only, but it is just advanced form of representation. But what I have said earlier, You cannot store like 8 is 8 dash b 1 2 3 4 5 6 7 8. This is not possible in your unpacked array because locations are different now. It is continuous location, you can use only on your packed array. Now declared outside the data type that I have told you, that right side of data type means your variable, useful for representing arrays of values and treated as group of individual variables. Individual variables, you know, and useful for representing arrays of values means if it is not a continuous location, so you can use as a variable. So you can use arrays of values means you can use as a values means variables. Can means if you are using prime number or anything, you have to use this method to generate your with the help of constraints. Okay, with unpacked array can be multi-dimensional and dynamically sized for dynamic arrays. Means it has multiple dimensions. Means you, as you have seen, 4 elements, and I will also show you the hybrid type of this array after this slide. When you want to collection of independent values, yes, stored in different locations, so values are independent, suitable for buffer, register files, and memories. Because memories we can store at different locations and there are different types of memories, so we have different type of method like packed and unpacked array for storing this. So yeah, next, so this is our hybrid array, mixed of packed and unpacked both. Hybrid array contains both packed and unpacked dimensions. Packed dimension defined with bit width or vector part, and unpacked array defined as collection of elements. So this is the general example. Our logic 8-bit of memory means we are just generating memory. This is also the format of declaring your array, like this is 15-bit, you can directly like 15. So this is the format. Okay, so I will give you an example. You can solve this example like okay, I will show you one time. So from 0 to 15 you have 8-bit of array like this. So these are 0 to 15 and this is of 0 to 8. This is a simple thing, but I will also show you one advanced concept of this also. So okay, giving you one easy, you can say, trick. So you can write, for example, you can write bit, you can say your width and array and your depth. So this is your simple type of array. So what is now here? 7 and your 15 means your depth is 15, means here is 15 and your width is here. So your array will be like this. It will be 2D array of 8-bit here and 15-bit here. Okay, like this. And if you want more than width and your depth, that is also possible. So it is like this. If you are writing bit only and here number of your width, here number of your, once more, okay, your bit, your number of your width of packed array, here is array, and here is your depth, and here is your number of your depth. So this is also the maximum your more than 4D array. For example, you are taking this 2, 2, 2 and 2. So this will be like one array will be here of 2 size, another array will be over 2, like packed array. We have done this packed array. Now we will do this. So depth is 2, so we will again make 2 here, again we will make 2 because number is 2, so we will make 2 of 2 means these 4 array will be there like this. This is your final answer. So for the another type of array like a city array and your dynamic array, subscribe my channel and I will make video for that also. So thank you, and if you need coding video for that, I will also make that. So thank you for your time.
Please tell me that I can't, that I won't, that I fail, that I'll never make it out, yeah. Please tell me all the bad, never good, fill my head full of every single doubt, yeah. Please